So, hi, I'm Jiří Staniševský. I guess most of you know me already, and I'm going to be presenting today about test-driven development of React hooks. Let's start with a bit of theory. I guess you all know what TDD or test-driven development is. It's kind of a methodology of software development where you first write tests, and then you iterate over your implementation to actually accommodate those tests. Sounds nice, kinda. And there are some flavors, additional flavors of this methodology. Now, some people actually found out, probably in a corporate, that when you're writing those tests, you kind of write them wrong because you don't respect the business requirements. So they came up with two separate new methodologies. One is called behavior-driven development, and the other one is acceptance test-driven development. And what they share the same idea, which is a brilliant idea, that you should check the business requirements first before writing those tests, and you can also you should also communicate with your business department. Well, duh. So a bit more about theory of TDD. So this is how the TDD process looks like. So this is how Wikipedia defines test-driven development. No, I'm just kidding. I won't be bothering you with nonsense and bullshit. Let's go rather, and I will share with you my impressions about TDD. What are the benefits? I mean, you get tests, right? This is the basic benefit of TDD because you want tests, right? Nobody wants to write them, so you need to force people to write them. So you say, first, write tests. Okay, thanks to that, you get a lot of regression tests for free, because if you keep those tests, which definitely you should, then you have regression tests. And the other benefit is that writing tests usually by itself forces you to write small units of code because you want your code to be easily testable. And if you are forced to write the test, then you will make sure that those units are small. What are the negatives? So basically the efforts, because if you're going to design the tests properly to meet all the business requirements and to ensure that the actual implementation will then follow those tests, you will probably need to invest as much energy as if you will be developing the feature itself. So that's a great con of this approach. And it also leads to something which I call anti-iterative development, because you get directly instructed how to develop your piece of software because you have those tests. So you just need to follow the tests and implement it. So it's like if you have a 70-page specification of your application and then you're just writing it like a monkey, which is something we developers don't like to do, right? So it kind of feels unnatural. And it also leads to imperfect software because you're just following what you're supposed to do, but not thinking about more. So what's the reality? I guess people don't like to write tests, so they do manual testing only. And the ultimate sentence is, let's write the test later once the feature is done and deployed and whatever. So this means let's never write those tests, right? Because that's what we do. Or we just write a very small cover a very small part of the feature. Or people think that some other department should do their work. So they think, okay, maybe QA does that. So if they don't, it's their problem. So ultimately, it all leads to no test at all. So when I wasn't different, I also didn't want to write tests because I found it like unnecessary. I was pretty confident with my code, and I enjoyed coding and not really writing tests. So that's what I did. And then I came to Ordamo, and I was asked to implement post-integration, which by itself is a very hard thing to do because it's like integration of third-party service, which is poorly documented, very random and unreliable. So you need a lot of iterations to actually come to a situation where you can say, yeah, it works. And Ordamo has a very slow build, so it takes ages until you really compile your code, even when it's an incremental build. And it's also complicated setup. There's many applications which you need to combine together. You need to configure a lot of stuff, so it's kind of time-consuming and to actually iterate over your implementation. So you make a change, and you need to go through all this stuff again, and then you found out that you didn't do it well, and stuff, etc., etc. For some reason, there was either missing source maps or broken source maps, so I couldn't even debug the backend. Okay, not speaking about front end because it's hard to debug anyway, but backend should be quite easily debuggable, but it wasn't. So, and I was also new to the project, so it was pretty hard for me to implement the required features. So what I did, I decided to develop almost everything against the tests. So I didn't need to build the application after each iteration. So I was significantly faster in testing my implementation. I could have mocked anything. So I mocked the configuration. I even, at some point, mocked the responses from the API because it took us like months to get the access to their API, but I had some examples, so I worked against the examples. And it was very easy to cover edge cases instead of clicking around and configuring dishes and modifiers and everything. I could just mock it, and it was working. And it was kind of a pleasant experience in the end. Yeah, of course, when the real stuff came, there were some issues, but it was mostly done by the time. So I like that. And I tried to follow it also now on the configurator project. And I invented something which is called LDD and BDD. LDD is laziness-driven development. It's where I actually don't want to click everywhere and to test my implementation. I want to be sure that it works. So what I do is first I iteratively implement. When I think that my feature is done, I start modeling the test to test my assumptions about the code. And believe me, in 90% of cases, my assumptions are wrong. I mean, not all of them, but at least one of them is wrong. So the test proves it. So I can fix it. Of course, thanks to that, I get regression tests for free because I covered most of the things that I know about the code, and it stays there, and I can run the tests anytime I want. It can be used for other people to understand the code because they can read the tests, and it's usually way easier to understand what the code does from the test than from the code itself. It's possible to identify the buggy units in a second because you have tests for your tiny units, and whenever there is a bug, the test shows at you at this particular unit. Then you can debug because it's all in test environment, so you can debug this particular test. There is no need to wait until the whole application starts. So it's pretty nice. And what is the biggest advantage is it builds a reliable and trustworthy layer of code which you can build on top of. So what I mean is that when I implement something on top of this already tested code, I trust the tested code, and I don't need to check that it works. Normally you would have a function which does something, then the function is used in a class, and then the class is used somewhere in a component, and you test the component from the browser, and then you need to test everything that it works correctly. And I don't need to, because I have the lower layers already tested, and I can trust them. So I test only the specific things for the new layers. So this is what I call LDD. And there's this BDD, a bug-driven development, which is something we should definitely follow everywhere. And it is when you encounter a bug. The easiest way for me to fix it is to create a new edge case, a new test case in the test, make it fail, and then fix the implementation and to see the green, and also see that all the other tests are still green, which proved to be very nice. So how does it work? How does these two new super methodologies work with React? I guess you are all the developers probably bootstrapped the application with the Create React app, and until recently, the only test which was in the application was this one, renders without errors. I mean, it's pretty amusing. Who would be testing your component that it doesn't render? I mean, you would see it immediately in your application, right? So this is, of course, nonsense. So what can we actually test with React? You can do snapshot testing. I mean, yeah, you have a component that renders into a markup, and then you test that the markup is still the same. It's broad to test everything. It's very strict, meaning that if you change a little piece of whatever, the test breaks. But it doesn't really mean that the functionality is broken, right? It's just you exchange one letter and it breaks. So yep, the implementation is frozen. You cannot really iterate over it. You cannot improve it without breaking your tests. And how would you set up a snapshot prior implementing something? I mean, you need to have a working code in order to generate the snapshot, and then you can test whether you broke the code. But you can never model assumptions about your code and then test whether those assumptions are correct, which is something which I find crappy about this snapshot testing. Not that they are not useful. They are definitely useful, but they are useful on small units when you really need to test something generated. So then they came with testing library for React testing library, which is close to a human-like testing and closer to end-to-end tests. So you have some selectors in your just test suite, and you're selecting elements on the virtual page and you're interacting with them. So you select a button based on a name, and then you tap the button and something happens. So it's not perfect either, because you test only a very specific part of the application and the rest can be totally broken. But it's a different approach, and I like that approach, kind of. Actually, if you bootstrap your application with Create React App right now, it's already importing this library and using this library by default. So how is it with hooks? Hooks, what are they? I mean, I cannot really go deep into explanation what hooks are, because I would spend 3 other brown bags about that. But let's say the benefits of hooks are a clear separation of concerns on a different axis than we are all used to. So it's not like with Redux that you have store and then you have view layer and then you have that. It's not like separation by technology, but separation by functional bundles or functional units, which you can just take and place somewhere and it works. It contains all the technologies that you need, or actually interacts with those technologies. That makes it very reusable, because you have a component as, I don't know, a form, and then you can place it somewhere else, and you don't need to care that there should be 2 instances in Redux, so 2 namespaces. You just place those 2 components somewhere and they work. And somebody claims that it makes React hooks more testable, which, well, React itself more testable, which I don't think it's true, because first, your function components are no longer pure because you're putting state in there, and that makes it a horror to test afterwards. So how do we actually test hooks? Well, we can use host components. So we create a component, we use the hook inside, and then we test the component. Yeah, so you're testing the component which uses hooks. You're not really testing the hook itself. So you cannot rely that the hook will provide all the features that it promises, because the component uses just part of them. So somebody came with a library called Jukes, which is like a concatenation of jest and hooks, which emulates the built-in hooks, all those use state, use effect, use ref, and whatever. And so you can treat your hooks as simple functions without any relation to React, because all the connection to React were the built-in hooks. So if you replace them, you don't need React to test your hooks. That's the approach. Clever idea, but somehow it disconnects you from React entirely. So you're kind of losing sense of how your hook is working together with React lifecycle. So the guys who created React testing library came up with an alternative, which is using which is using something like a hidden host component. They create the component for you. They hide it somewhere underneath their API and then present a nice and simple API to interact with that component and to drive its lifecycle to you. And that's something I will be talking more about in the demo. All the demos that I will be showing you are in this repository of mine, so you feel free to take a look. And let's dive into code. It's visible properly, right? So let's write our first hook. For some of you, probably it will be really the first hook, so I will go a bit more slowly. So React hooks come up with built-in hooks like useState. useState is something that returns the actual state and the callback with which you can change it. And we're going to extend or maybe restrict this useState to a Boolean value which can be toggled. So you cannot set it to true or to false. You can just toggle it true, false, true, false, true, false. So what our function is going to return, actually the hook is a function, right? So what is the hook going to return is a Boolean state, true or false, and the callback that will change that state. So what do we need? We need a state, somewhere to keep this Boolean state inside in that state. So in React hooks, with React hooks, you do it this way. You initialize it to initial value. And then we already know that this is a Boolean state, so we can just forward it out of our hook. And we can say that here, once this is called, we say set state and not state. It's just a simple version. I'm pretty happy with that. Cool. So our hook is working. So how would we test this? We would put it in a component, render it on a web page. Then you would need to start the dev server, go to the browser, tap and tap and tap and tap quickly, so you can test. So you test all the edge cases, and then you will be happy with your implementation. And somebody then will find errors later on because there are some issues here. So let's do it in an LDD way. So if we go to we're going to write a test. So I'm not going to write because it would take ages, so I'm going to use my computer memory. So what do we do here? This is our hook. We are rendering it with an initial value of false, and we are rendering it using this render hook helper function, which is coming from the library that I spoke about. And this library is returning, among other useful functions and objects, this result stuff. Result is something you can imagine that it's something like a ref. If you ever worked with use ref from hooks, it's returning it has a current property, and this current property is always has the recent value of the hook that you have rendered. You see that we are actually here returning the values from the hook, so it goes to the library, and the library processes it and populates this current stuff here. This first test here is saying that it returns expected types. This is a very dummy test for beginning. So you can see that I'm checking whether the type of the first entry in the tuple is a Boolean, and the second one should be a function. I'm not destructuring this array here because this current is a mutable object, so it will change in time. Right now, not, because we are rendering it only once. The hook is rendered only once, so it's still the same value. But for consistency, I'm not destructuring it even now. We will see later what I mean by that. So right now we tested that the function returns proper types. What else? Okay, we need to see that it toggles the value, right? If you call the callback, then it should toggle the value. So once again, we render the hook with an initial value. We can check that the initial value is false because that's what we wanted. And then we act. Acting is, I guess, probably you already wrote some tests in React, so you know that there's this special function which emulates user interactions with the page or whatever. So every mutation to your virtual page should be wrapped in this act callback. So what I'm doing here, I'm calling this second element of the tuple. That means the callback that toggle the value. So calling it and then expecting it to be true. Simple. What else? Toggles bear and deck again. What would you expect if you call the toggle twice after each other? I would expect that it toggles to one value and then toggles back to the previous one, right? So that's what we are testing here. We have initial value, we're toggling twice, and then we expect it to be still the initial value because it should be toggled to true first and then to false. Great. What next? Okay, because I tend to do a lot of premature optimizations. I like if my hooks, when I'm writing them, are allowing me to optimize my code. So if you use useState, you know that this setState callback, which is returned to you, is always the same function. It never changes in instance. So I want this hook to do the same. So if I'm using useCallback, I have this toggle callback, which is the second element of the tuple. When I call it, I want the new one to be the old one. Okay, that's all for the test now. So let's run them and see what happens. You can see that I have my superior IDE here, so I can run my test directly from there. Even though, of course, I can use the terminal. So you see that the expected types are properly returned. It toggles, but it doesn't toggle there and back again. And it doesn't return reference table callback. You could probably expect that because we are creating a new function all the time in the hook. But this one might be a bit confusing. But if you are a bit experienced with React, you will know where we made a mistake. So I'm not going to go into the detail, but this value here is captured, and if you call the callback twice, you're still using the same captured value, so you're setting true and true twice instead of setting true and false. So how do we do it? We just use this this alternative signature to set state, where we are actually getting the latest value in the state in the callback, and we just negate it, and that's it. So now if you run the test, it should be more greeny. Yes, it is. And the second thing is just to memorize this callback, which is pretty easy. Let's call it toggle, and then we just wrap it with use callback. Yes, and we just need to define the dependencies, import, and run. Cool, all green. So now we are done with our hook, and we can freely integrate it into our web page, and we know that whatever we do with it will be fine because all the expected behavior is working correctly. So if I go where I go here, I don't know if it will be working right now because maybe I broke something. Okay, it's not working. Yeah. So we have this ASCII checkbox, which is just a piece of text, which renders the checkbox and uses the use toggle inside. So if we can even look at the ASCII checkbox implementation, which is pretty simple, right? It contains only usage of this hook, then passes the callback to a click handler and renders the X or not X. So you can use this use toggle anywhere you want where you are using a toggleable value, like collapsing and expanding an accordion or whatever. These are like 4 lines of code, but it makes your other code look much easier to read and much nicer. So that's like a promo for hooks. Okay, now let's go further. Let's do something a bit more complicated. So let's say we have use autosave function hook. What we wanted to do is that it takes some kind of data, random data, and an URL, and it will forward this data to the URL, actually post it anytime the data changes. So with hooks, it's kind of easy because you just use effect here. You use effect, and you specify data as dependency, which will make sure that every time the data changes, the effect will be triggered and it will be saved. There is a little hassle of using asynchronous functions in effect, so you first create a function and then call it, but that's really irrelevant. I guess you can imagine what it does, right? It just uses fetch to fetch it and to store it on the server. So let's go. Well, let's say we're happy with our implementation. So let's go to tests and let's write some tests. So first, what we need to do, anybody who used Jest for some more advanced tests knows that we can spy on something. We can make mock functions. So here we are spying on global object and actually try mocking the fetch function. We're using a mock fetch implementation. We can take a look. You see there is something happening. It's pretty complex. So it would take me minutes to read. So why not instead go to the tests of that mock fetch function? And so what we see here, the mock fetch responds with specified HTTP status. So I can see that if I call it with this URL, it sounds like idiomatic. So it's respond in 10 milliseconds with 204. It will respond with 204. If I say with 200, it will respond with 200. Oh, I can even pass some payload here. Okay, maybe it will be described in another test. Yeah, responds with specified payload. So if I specify payload, it gets the payload back. Okay, cool. So you can really use your tests as explanation what your code is doing, because if I would be inferring this from the code, it would take me at least 5 minutes to actually find out what it does. And then I would I would complain about code style because it's not written according to my standards, and it would be disturbing. This one, it's pretty easy. So I go to autosave again. Oh no, so the specs, yeah. So we're mocking the fetch function, and let's start writing some tests. So the first one would be that we wanted to save when we first render, because we got new data, so we want to save it. So how do we test it? Easily, we just render the hook. In this case, we have this fetch spy, and we can check whether it was called. That's pretty easy. What else? It does not save when the data didn't change, because we don't want the same data to be sent to the server each time the hook renders, right? So we render the hook again. We get back a function which is called re-render from the library, and we check that the fetch spy was called. That was the initial save, and then we re-render the hook, and we can check that the spy was still called only once, so it wasn't saved once again because the data didn't change. Next is that we want to definitely test whether it saves the data when it actually changes. So we have, again, render hook, we have, again, render stuff, but the data which we are sending is not fixed here. It's coming from outside. There is multiple ways. The library offers multiple ways how to pass data into your hooks, but I find this one the simplest one and the most clear one. So you have an object. You can call it props. You can call it whatever. You have a data there. The object itself is mutable. So anytime the hook renders, it takes the actual data from the object. So what we do here, we just change the data in the object and call re-render. So it will re-render the hook with new data, meaning that it should actually save again. So it should save twice in the end. Cool. Next, it should report saving state. Yeah, that's okay. That's a new requirement actually, because if you look at the page right now, I do say it. I don't know even if it works, but if I take a look at the network traffic, I can see that it works. It's sending something somewhere. But I don't see it in the GUI, so I don't even know whether it's being saved. I don't know if it takes ages to save it. So I would like some kind of an indicator that it works. So we can now play the TDD role game. We can just define the test first. There's something called saving state, and we say that we wait until that we want to know whether the request is actually pending, so it's saving, or it's already idle. So we go back to So we go back to our hook, and we implement the functionality. So we define a state, and we change that state. Once we try saving, we mark it as being saved, and once it's successfully done, we mark it as idle, and if it fails, then we mark it as an error. We just need to dependency here. Of course, we need to return the state from the hook. Okay. Oh, crap. Sorry. So now if I run, did I change something? No. If I run those tests here, they should be green, hopefully. Cool, they are green. The last thing is we want to know that it reports that there was an error during saving, right? So we deliberately request 403, for example, a status code from the server. This is our mock fetch, so it's not actually contacting any server, it's just calling the function, and this function will return 403. And let's test it, okay? So we did it in the same way like here. It's going to be saving, then we're going to wait. I didn't explain the wait for next update, but I guess it's kind of obvious. So if you get this wait for next update callback from the render hook, and then you can call it and await it, and it will wait until your hook renders again. Pretty simple. So that's what we did, because it will render again once we change the state to idle when the response comes back from the server. We do the same here, exactly the same stuff, except for checking the error here. Let's try whether it works. You see I can run only one test easily in my superior IDE. And it doesn't work. Why doesn't it work? I'm sending 403. I'm pretty sure that the mock fetch works because it's tested. So something needs to be wrong in here then. Okay, let's go there. This is not, you could debug, you could just check the response here, but probably you know that fetch doesn't fail if it receives a failure code from the server. It just returns the response and says the response has a status code of 403. So you need to check the OK property. Okay, and now if you're really into hooks, now you start thinking, this is getting more and more complicated, bigger and bigger. Maybe it's time to do a bit of refactoring. So instead of bundling everything inside this use autosave, which is which area of effect is pretty niche. So we rather create a hook which works in general way. So we create a use fetch JSON. Here's the hook, because we can use it for everything, for saving or retrieving, for everything. So we use fetch JSON. Okay, then let's do fetch JSON. Fetch JSON is a bit more complicated, but in general is the same. You see that I'm returning a callback here, and this callback is just fetching a JSON, which is another function here, which doesn't do anything else than fetches the result and then parses the JSON. And once it's done, it sets the idle state and error. Apart from that, you can see that it's actually setting a tuple instead of this state only, and the tuple consists from the actual value that's returned from the server, in case of here, JSON, the state, and an eventual error. I got inspired that Apollo client because they do it the same way, and it's pretty neat. So from this useFetchJSON, we get back not only the execute function, which actually performs this request, but also the state of that last request. So we get the value, we get the state, and we get an eventual error. So just briefly, let's write tests for that. I mean, I'm not going to write it one by one anymore because we are running out of time, but just briefly. So the fetch JSON should be idle when it's mounted because we need to call the function in order to initiate the request. So we know that it's function, and that then this tuple equals to undefined, idle, undefined, because there is no value, there is no error, and it's idle. When you call it again in the act, it should be undefined, pending, and undefined because it's triggered. It has triggered the request, and it can pull data. So if we wait for the request to finish, we should be able to see that the JSON is actually populated in the value, and it's still again idle and error, and there is no error. Similarly, when it's error, then it should report error, and it should also say which error it is. And it should also report generic error if we ask for it. It's not really important. Yeah, and probably you want this use fetch JSON to actually ignore the result of a previous pending request if you send another one. Let's say I want to search, and I'm searching for A, so it would trigger a request for A, and we expect it to return the list of entries which are matching A. And if I type B, then it should be AB, and we're asking for AB. Of course, we are not interested about this A anymore, so we should ignore it. So that's what this test is doing. It's trying to wait. Actually, you see it's firing a request that should take 200 milliseconds. After 50 milliseconds, it triggers another one which should take only 100 milliseconds. So what we should get is this new value, and we should never get the old one because it was superseded by this one. So that's what we do here. We're checking whether the new state was set. Yes, that's correct. And then we are waiting for another update. And if that update doesn't work, it doesn't come in 200 milliseconds, we know that the previous response was ignored. So let's run those tests. How is it done? Is it okay? 15 minutes. Okay, that's cool. So it's looking pretty greeny, except for the last bit. So again, our assumption was wrong, so we need to fix it. We go in. This is really just a tiny bit. How we can fix it, for example, using a magical token. Oh, this one not. So we actually have a ref which contains like a property that contains a token, which is an object. And during each call to the server, we generate a new token, and then we compare whether the token is still the same as the previous one. And if it is, then our update is desirable. If it's not, then our update should be ignored. Simple, easy, green. Yep. Okay, and now the benefits of having the regression tests. So we would go to use autosave and replace the implementation with the usage of this use fetch JSON. I'm not going to do it because I have it prepared here. So we just have another use autosave too. And what we did is just we use fetch JSON. We have this save callback and the state, and that's what we do. We call the save method and return the state. Easy. And the tests, they look entirely the same. Like before, I could even show you if you want the proof. Where is it? What? Control D. Yeah, that would be the easiest way. Right. Okay, that's not working because I don't have two of them selected. Yeah, so the only thing which is changed is the name of the hook, and that's it. And also these states, because we are now using fetch state instead of saving state. So the tests are the same, so we can run. We can see whether we broke something. Sounds good. So we can use that. we can use that in autosave input now. So if I do autosave 2, come on. And this one as well. Now in the browser, we should have this saving. You see it's blinking there. If I say that I'm on slow network, it will stay there for a bit longer. So that's how you write basic tests with this this library. Do we still have time? Okay, then one more example. It's you know, the hooks are not always working in a complete isolation. You have usually the hooks are reaching out for values from context. So how does it then work? I mean, we have something called useBusy here, which is just another hook that keeps a state somewhere on top of the hierarchy, saying that the application is busy, and the components themselves can say I'm busy, I'm not busy, and then it's somehow combined, and the application gets notified whether it's actually busy or not. For that to work, there needs to be a context provider hooked up in somewhere in the application. So if I see it in the code, you see there is this busy provider with a signal, which is something that shows whether it's busy or not, and then you have those elements. So to make it work, I just need to come on, just need to go here and revert this one. Now it should even work in the browser once it reloads. Yeah, well, I shouldn't be reloading on a slow network. You see, it blinks with red. That's the busy. Notification. And we would expect it to work with tests as well, because we didn't change anything significant. So we go here, we run the tests again. And not surprisingly, some of them will fail. Well, it's surprising that only some of them will fail, but I will explain it later. So it says useBusy can be used only within the scope of busy provider. So we need to wrap our hook somehow into the provider. We can do it very easily. Where am I? Yes, here. There's an option that you can pass to render hook called wrapper. It's just a component that takes children and renders the children underneath itself. So you can wrap anything in anything. It can be your own component. Definitely, it doesn't need to be the provider itself, because the provider can have more complicated signature. So you write your own component that wraps everything. So we wrap it. We wrap that everywhere, and it should be green. And then let's check. And it's green. Everything works correctly. So this is how you use context in this testing library. Maybe you wonder why only some of those tests were failing and not all of them, because we are using this autosave everywhere, and you can see that directly in the hook we are using this useBusy, and this useBusy is directly checking that the context is there, and it should throw an error. It actually does throw an error, but until recently I found that this library tries to do more than it should, and it catches the error, unfortunately, but it doesn't catch it everywhere. So you have two behaviors. Sometimes during the rendering it catches it, and it presents it as a result. In the result there is an error object which contains the error that was thrown inside. I find this pretty disgusting, because you know, theoretically in all the tests, then you should write expect result error to be undefined, right? So everywhere you would need to do this, and also once you re-render, then you should do it, and it's pretty annoying. I've already posted a message to the guy who's in charge of this, trying to find out how he's deciding, because he said maybe we don't need to catch it at all. So I'm just trying to support this in his idea, because I don't really see any reason why would you do that. If you want to prove that your hook throws an error, there is a mechanism in Jest for that. You can say that the function, you can pass a function and say expect to throw, and it should work. So this is a big caveat of this library. But otherwise, it's looking nice, and I really like using it. Last thing, get back to the presentation. The experience that we have with it on Configurator SDK is that we have nearly 200 organic tests. I say organic because we needed them. We actually did it because we needed them, not because we were describing an existing code. It found a lot of errors in the initial implementation, a lot of false assumptions, and it allowed very quick and extensive refactoring of the underlying code because we had the regression tests. And what's the most beneficial thing is that it provided a very reliable low-level layer of code, which we are building on top of, and we can be sure that it works. And that's why we didn't have that much bugs, I guess. And that's it. If you have any questions, feel free to ask right now, or you can reach me on Slack.
So nowadays with this approach, how often do you end up writing the tests before you do the implementation?
Sorry, what again?
Is it more like common for you to write the test first now, or just implement it and then write the test after?
I am implementing the feature and then writing the test later. But it's not like I'm writing it after I test everything in the browser. I just implement the feature, the low-level feature, and I write tests to actually validate that the feature works. And then I integrate it into the application.
Okay, so you never write the test first?
No, I don't. Because I'm pretty used to iterate heavily. So I make one signature, then I completely discard it and create a different one because I found out that my initial design was wrong. And so I kind of iterate a lot, and that would mean that I need to change the tests a lot. And
all right, thanks.
Write tests.